So hi, I'm Rainer. I'm a dev at Microsoft. I work in the Tools for Software Engineers team, working on MS Build primarily, and that's roughly under the umbrella. Technically, my vice president is the vice president of Visual Studio Team Services, the TFS online cloud system, but it's close enough to Visual Studio. My code ships mostly in Visual Studio, so knew a thing or two about what's going on with Visual Studio, and I had access, the same as y'all, to the release notes, so I was able to go through and figure out some cool stuff to demo. And then, we'll talk a little bit about what's new in general. I've got a few things. This is totally, I should probably say, this is not a marketing approved presentation. This is what I thought was neat and could get demos for while I'm on paternity leave and the baby was napping. So this is not super slick. Look how awesome this dev demo is. My apologies. And also, this is totally not everything. Visual Studio is a big team. 15.3 is a big update. It's the first big update. We've been moving into this cadence on the Visual Studio teams of smaller focused updates and then bigger updates. 15.3 is the first one to pull the big update lever, basically. There's a lot of people, they've been working on a lot of stuff. There's a lot of improvements in C++, in cross-platform native code development. But since this is the C# group, I'm going to focus on some of those things. And then toward the end, I'm going to go into a deep dive on a new feature that's available more or less at the beta level in 15.3. So I'd like you all to pound on it and get it ready for everybody else to use once we're ready there. All right, so live coding demos, what could go wrong? We already established that a lot can go wrong because I'm not going to be able to do the second half of this first demo. So one of the big focuses in the 15.3 release was on accessibility. So if you've ever used a screen reader or any of the various assistive technologies that Windows and other OSs provide, Visual Studio had a lot of focus. I think there were 1,700 commits in the 15.3 release that were tagged for accessibility or 1,700 bug fixes, so there's a ton of work that goes on. I'm not a screen reader user. I don't have one installed on my machine, so I can't demo that, but apparently trying to use the debugger in Visual Studio if you had a screen reader hooked up before was a very painful experience, and now it's pretty good. A lot of the, the little things that pop up as you're typing your code to do completions or to do suggestions and things like that were very hard to access because it's one of those things where when you're not thinking about accessibility, you just say, oh, I'll just overlay it here, but then you got to figure out, oh, how does that happen when you're reading the screen, that sort of thing. A lot of that work has been done. It's supposed to be a lot better. So if anybody does use those assistive technologies, 1, give it a try again, pound on it. 2, it should be a lot better. 3, please file feedback and other bugs if you see any problems. That's something that the team is very focused on, and like we really want Visual Studio to be accessible to everyone. One thing that is new that's easy to demo is there's a new color scheme called blue high contrast. So it's kind of hard to tell, especially in projection mode. One thing is, this is great if you've got visual problems and seeing the kind of like light colors on the screen on a light background was hard for you. It's also great when you're presenting and it's a little washed out on a projector, so I'm probably going to use this all the time now. But some of the additional colors are a little darker, a little easier to see and higher things, so I'll use that all the time. So I mentioned filing bugs. Quick plug. There's this little icon up here since now where you can click and report a problem or provide a suggestion. And as it does its thing, so this opens up this Visual Studio feedback application and window. It gives you a nice search box. There are all these things that you can come in, you can upvote issues. So I know you're all devs. I know you've all received bad bug reports. Please do us a favor, and when you're filing bug reports, we know you're devs. We all know you're devs. All of our users are devs. It's a dev tool. We get some very bad bug reports. Please don't be one of those. Don't say, oh, it crashed. Yes, thank you. I can totally fix that. All right? So, and of course, duplicates don't really help, but we totally do sort by upvotes and then work down the list when we're trying to figure out what people are worried about. So search, try to find your issue. If you can't find one, there's this report new problem button down at the bottom, way under the search box. You click that and it tells you to search. So please do search. And it gives you some other tips that I hope you know. Use a nice, clear, specific title. File separate issues if you've got multiple bugs. If you're going to say, you can say, if I do this and then this happens, that's a bug, right? If you say, this happens and this other totally unrelated things happens, that's 2 bugs. So please do file multiple bugs. There's not a penalty for that. And suggestions are a slightly different system. When you file a feedback issue, that's just a bug. In our internal VSTS system, it's a separate work item type, but it's just a bug. It gets assigned like everything else. We triage them. We go through the usual processes. So that goes directly to Microsoft engineers. Sometimes it takes a little while to bubble around to figure out exactly which team is the problem here, but having good keywords and good descriptions will help with that. So you can file a new bug demo, and then okay, I know there are 4 sharp. That's pretty unique. Not really going to submit this. One of the things that you can do in this attachments tab, you can include screenshots so you can show, oh, like this is wrong, this is not right. You can also do this record option. This captures an ETW trace, which allows us to see, especially for performance issues, this is so helpful to us, because if you say, hey, it takes 5 seconds between when I click on this thing and the next screen appears, if you can start a trace, reproduce that, stop the trace, come back and upload that trace to us, we can see in PerfView, we can go in and see, this method is taking a really long time. Let's figure out what's going on. And so that is hugely important. So if you can provide that level of debugging information, that really improves the chance of getting a nice fix in a patch for y'all. So definitely do that. Okay, so pitch on giving us feedback. All right, now I'll actually talk about good stuff. Who does web development? Not me, but I'm going to talk about it as though I know what I'm talking about anyway. Has anybody played with Azure Functions yet? Okay, so who knows about serverless? A little bit? All right, so serverless is this new cloud computation idea of it's one thing to get a virtual machine in the cloud and I provision IIS and then I ship my code in some way and I have to do all my deployment stuff. And there's varying levels of how much work do you have to do from I have some code to it's running in the cloud. Azure Functions is a way to minimize that. So with Azure Functions, you can really just write like the method that you actually care about that responds to an HTTP request, and then you can ship that to the cloud. So that's something that's been out for a little while. New in Visual Studio 15.3 is, wait, I'm not supposed to say that. New in Visual Studio 2017 Update 3 is the official marketing name that we're supposed to use all the time. I'm not going to do that anymore. It's 15.3. New in 15.3 is the ability to run those locally, debug them using the normal experience, and deploy directly to the cloud, which is the part of this demo that I was just saying has gone horribly wrong this morning, and I don't know why, sorry. So you'll just have to take my word for it that the debugger, that you can deploy these things to the cloud. So this is just a super simple hello world, right? Come in on this route, provide a name as a variable. That comes in as a string, return hello name. But you can just use standard F5 and the Azure Function runtime for local development comes up in the background. And we'll start a local copy of a web server stack that's very similar to the one that happens in the cloud. Spit out a URL for you. And then, oh, I set a breakpoint, so here I am. So I can come in, use the usual hotkeys and things. One new feature in Visual Studio 2017 is this run to here hover button. There's always been a right click and then find the thing that says run to cursor. But now it appears on a line of code just right there. New in 15.3, if you hold control, it turns into a set next statement button. So you can just come back, that's hugely important for the way I use this feature, which is always like, there it is. Like, let me come back to here. Before you could drag the little execution arrow around or right click. Now it's a nicer UI. So new in 2015, or new in 15.3. Someday the numbers will diverge enough that it's not confusing anymore. So then here's an example of, okay, so like obviously hello world, not super exciting. It was supposed to be super cool when I said, now I've deployed it to the cloud and it's someone else's problem to operate it, except someone else has broken my demo. So please give this a try especially if you're using Azure, the Azure ecosystem at all. It's really pretty cool. And there are many, so let me show you the new project template. So if you come in and say new Azure function in an Azure function project, it's not just HTTP requests as incoming triggers. There's things like, you can say, GitHub webhooks. So like whenever someone makes a comment on an issue on your GitHub, it'll call your hunk of code, and you don't have to hook up any of the watching stuff and that sort of thing. So you can do blob storage when something gets dropped into blob storage, run this function, and all sorts of things like that. So play with that a little bit, and now the debugging experience is available inside Visual Studio. Hooray! Okay, so that's Azure Functions. One of the other headline features of 15.3 is support for .NET Core 2.0. So we've talked about .NET Core a lot in this group because several of us are interested in it. That's what I've been doing a lot of work on .NET Core 2 support in my day job. .NET Core 2 is now available. It got released at the same time as 15.3. And if you install the SDK, one note, you must install the .NET Core 2.0 SDK separately from Visual Studio. Within Visual Studio, if you check the right boxes, you'll get a .NET Core 1.1, and you'll be a little confused, and you'll file one of 1,000 duplicate bugs that we have that says, hey, you're supposed to support .NET Core 2, and it's like, yeah, go install .NET Core 2, and then we'll support it. So please do install that separately. So what's new in .NET Core 2? It's a lot like .NET Core 1, so that brings a lot of the cool new features like edit projects, not forcing you to unload and then edit as a text file, but working live. Like, here is the whole project using the SDK imports feature that I talked about the last time I was here. And like, I don't think I actually have any NuGet package, or I have some in here, let's see. And like having NuGet package references in your CSproj file, not having to carry around an extraneous file. What's new in .NET Core 2 is there are two new target frameworks. There's .NET Core, or there's .NET Core App 2.0. That's for command line applications that run on .NET Core. And then there's, Net Standard 2.0. Net Standard 2 is a big change because it's a lot bigger than Net Standard 1.x. Net Standard 2 is much closer to the surface area of the full .NET framework. So that means that it should be much easier to port to .NET Standard 2 than it was to .NET Standard 1.x, because the APIs that the .NET framework team wishes you weren't using because they have a shiny new version, but everyone is still using, are actually available now. So this is something where, like, if I could have taken this back in time to when we were porting our code to .NET Standard, I would have loved it. And once we can get fully in the groove and just assume that we're targeting this exactly, we're going to remove a ton of if-defs from our code where we had to do if So, like if full framework, do it one nice way. Else, if .NET Standard, use a different set of APIs, almost all of that is gone. Not everything is available everywhere, of course. Like if you're trying to use registry APIs on Linux, you should probably rethink that. But the API surface is much bigger. So all of the things that you would expect work, including things like, right-click build. All that works in Visual Studio, so .NET Core 2.0, you shouldn't even notice. Yeah. Yeah. So the question is, where if you write something and it's a Net Standard 2.0 library, where does it work? So, great question. The answer is it works on any .NET runtime that is .NET Standard 2.0 compatible. We have 3 of those. The full framework, so .NET, like installed in Windows, 4.6.1 and higher supports that. .NET Core 2.0 and higher supports that. So, and .NET Core runs on Linux, macOS, and Windows. And there are ports in progress of various levels of quality. So if you really need to run it on BSD, it might work right now. It might not work. It's not officially a released Microsoft product, but people are working on it. And Tizen is also supported, I believe, officially. And then there's also the mono runtime, which works a lot of places, plus is embeddable. So for example, if you're using the Xamarin tools to build iPhone apps or something like that, you can use a lot of .NET Standards 2 stuff. It's all kind of new because a lot of this is like we retroactively define, so like .NET 4.6.1 came out before .NET Standard 2 was even a concept that existed. So there can be some rough edges there, but in general it really works very nicely. And if you have a library up on NuGet, I highly encourage, and it's not super tied to Windows or the exact implementation of .NET on Windows. I would highly recommend that you start thinking about, if you haven't already, getting a .NET Standard 2.0 version of that library out. It should be very little work. Should mostly just be reconfiguring it, maybe redoing your project files to support the nice new file, and getting to delete a ton of code out of that, which is not terrible. And then that's very compatible, and we're pushing the ecosystem in that direction, so please do. Okay, so within .NET Standard, or within 15.3, there's a new compiler, as you would expect. And this new compiler doesn't just bring bug fixes. The new C# compiler, Roslyn 2.3, supports the language C# 7.1, which has a few new features relative to C# 7 that shipped with VS15. Nothing huge, nothing that you have to scramble to adopt, but some that are very, very nice. Has anyone used async and await? Hopefully, awesome. Has anyone used async and await in a console app and been really annoyed when you get, because it's infectious, right? So if you've got an await inside a method, that method needs to be async, and then it goes up and up and up, right? And then you get to main, and the compiler says you must have something that is not async as a main method. So then you have to come in and manually do the process to take a task, get its awaiter, get its result. And this isn't like the world's worst code to have to write, but it's a pain, and the compiler can do it for you now. So if you opt into C# 7.1, you can just come along and say await, and then it's not async void, it's async task. All right, and then that should just build, let's see, does it, so there we go. So that failed, and the reason it failed, let me go back to, there we go, error list. I am not going to a meeting right now. All right, so it gave me the usual error. Hey, you don't have a static non-async main. That is because this is a highly compatible update. You must opt in to new language features. So you need to come over to the project, right-click, go to Properties, go to Build, go to Advanced. This is a new feature. If nothing is specified in your project, it defaults to the latest major version, which is 7.0. So you get all the tuple goodness, but not async main and the other things we're going to talk about in a minute. You can opt in either to latest, which will always be the latest, and when you have Visual Studio 15.5 installed, it'll be 7.2 or whatever comes out with that, and so on. Or you can explicitly specify a level. You've been able to do this for a while. Now there's UI for it, which is nice. So you can come in and if you explicitly opt in and say, I'm going to target C# 7.1, and then save, and then build, now it works because the compiler knows to go in and say, anytime you have an await in your main, go ahead and rewrite it. So the output of this is going to be almost identical to what was just there where we have the manual awaiting, but you don't have to do the manual awaiting, which is nice. Anyone played with tuples in C# 7? They're pretty cool, and one nice thing about them is like you have the .item1, .item2 of the generic tuple, but then you can also name the fields inside of tuple, right? So you can say, here's a path and here's a hash. So like this tuple has .path and .hash, and that's a nice way to access it. But the compiler people saw this kind of thing too much, where you say word : to name the field, and then the same word because it's just like you just need whatever this thing is. So a new feature in C# 7.1 is if you use a variable, it will infer the name of the field to match that variable. So I can just cut that out, and this is still compilable because there's still a path member of that tuple, because we expect that's what it is, right? If you want to overwrite it, use the old syntax and use your own names, that's totally fine, but now you can do it by default. Speaking of default, hey, what a segue. Have you ever written library code like I know you don't know what a dictionary is. There we go. All right. So here's a new feature. A lot of times you type capital T type name space lowercase t type name because you just need a thing to hold that type. And before that was always something you had to type. Now there's a default suggestion of, oh, let's just name, like you can name the variable your type. So let's just go ahead and use that. So one thing in previous versions of C#, if you want a default value, so null for nullable types and zero, like bit 0 for value types, you had to type default, which is a language keyword, and then inside the parentheses you had to type the full type. A lot of times you don't actually need, like the compiler can know what all that stuff is, so now this is legal. You can just say default. And because the type of this thing is defined, and the compiler knows what it is, it's right here, you don't have to deal with it. This is especially useful deep inside generic things where you got multiple generic type parameters going in, and you got to figure out like, hey, maybe that's a struct or maybe that's a class, and you don't really know because you don't know how people are using it when you're writing the generic code. So now you can just say default, and you don't have to fill in all that junk. Not a huge feature, again, a little nicety. So that's the theme of the C# 7.1 features. All right. Okay, so the next feature is available only in Visual Studio Enterprise. So hopefully you're all paying for Visual Studio Enterprise because I assume that's how my salary is getting paid. But it offers a cool feature, which is called live unit testing. This is new with 2017. I'm going to say the word in crunch so that you know that I have heard of it. I'm not going to address it further. So I came in and I said, live unit testing start. And then I don't actually have tests for this because it's a terrible demo application. No, don't move anything. Did I accidentally drag? Okay, so you'll notice that I didn't, well, you may not notice, but I promise. I didn't hit F5, I didn't hit build. None of that happened, but it ran some tests for me. That's because it happens live. So I've got this terrible function here that I am running that calls into a very boring, standard, recursive, inefficient implementation of the Fibonacci sequence. So just recurse with n-1, n-2. And I got all these green checks because this is covered by a test that runs. So live unit testing is coming along and getting code coverage for me, figuring out what affects what tests, and then building the tests and running it in the background. And it's giving you a view. So why is it called live unit testing? Because I can come along here and I can break this, and I literally just hit one key. I didn't save the document, I didn't build, I didn't say run tests, but it knows it's broken because the live document that is edited has changed from the disk. So in the background, it went and rebuilt, ran tests, discovered that they failed, and marks it as failure. And then you can come along and say, oh, it's covered by a test. Let me see that test. Okay, it's this test. So that's super nice for if you've got good unit tests, they run quickly in the background. That's not a hard requirement, but it helps. Then you can discover things like, oh, I broke some other thing as I was going along doing this. So live unit testing, new in 2017, cool feature. What's new in 15.3 is works for .NET Core 2.0. It didn't work for .NET Core before, now it does. So this is a 2.0 set of things. I got net standard libraries, and the test project is .NET Core App 2. So that all just works as you would hope, and now it does. So that's the less exciting kind of feature is you assumed it worked before, but now it actually works and does. So awesome. All right, so that's that. Now let's see. Let's get a command prompt open so I can feel at home. And I'll show you one of my new. That big enough? All right, so okay, so here's what I worked on. Sorry, that's what you get. So one of the things that is new in MS Build in 15.3, we have a few features. .NET Core 2 support is a big one. But the biggest user-facing feature that we have is this addition of a binary log. So when I was here last time, I talked about diagnosing what's going wrong with your build. And I said basically, like, I always want to see a log that has the verbosity cranked up to the max. And it's really huge and intimidating, and it slows things down a little bit, but it has all the information that your build expert person, which is hopefully y'all, needs to figure out what has gone on in the build. With MS Build 15.3, we added a new command line switch or argument that you can pass called the binary logger. And hold on, let me do it. So let me just build at low verbosity, low console verbosity. What has happened is there's this msbuild.bin log. Of course, you can control the name. And this is a binary log format, so it contains exactly all of the information as we're generating the log events. So we're not throwing anything away. And it's compressed, so it's very small and it has much less of an impact on build performance. So I highly, highly, highly recommend go to all of your build servers as soon as they're on 15.3 and higher. Go to all your build definitions, turn on the binary logger, and capture it. Because that will make it super nice the next time you have a build problem and you need to diagnose it. So this is a lower impact thing, and it contains all the information that you need. So what you can do is you can replay that. So I can say MS Build, And then instead of a project to build, I can say, build this binary log. And then I can say, with a file logger at diagnostic verbosity. And then that spits out the console log that I want, plus it's doing the defaults, or here's the default console log, plus it spit out the text log, msbuild.log. And so you can see there's actually more information in the binary log that's 1.5 megs instead of 30, because it has things like timestamps and things that aren't in our default text logging. So turn that on, it's very nice. Another thing that supports it that is not an official Microsoft product, but that our friend Kirill works on is there's a thing called the structured log viewer, which I have installed on this machine, which gives you this nice tree view of here are the projects. So like here's the solution. It built these other projects. This project did a bunch of things. It had all these targets, and so on. And it's got a nice search, and if there's an error, it'll pop up, and there's a very nice thing. So this gives you some visualization. He's also recently added a timeline, so you can see what's happening where. That's still early. I like my timeline thing that I pushed a little better, but that's just me being annoying. Totally turn that on all your builds. But it will break if you ever need to use an older version of MS Build. So as soon as you can go to 15.3 for your build definition, do so and then turn that on, because it's awesome. Okay, so the other big feature in MS Build was something that we worked on with the Roslyn C# compiler team, C# NVB compiler team, and it's a feature called reference assemblies. And so, as with other features, the question is, why are we doing this? And the answer is succinctly expressed by an XKCD that I'm sure you all recognize. Because building stuff takes a long time, and anything you can do to reduce that time is nice. So one thing is, hey, you can use C#, which takes a lot less time to compile than C++ most of the time. So awesome, right? But depending on the shape of your solution, it can still be too slow, right? So one of the big reasons for that is you've got a bunch of projects that produce a bunch of assemblies. For example, you might have a setup like this. Enjoy my beautiful drawing skills. So suppose this is your solution and you got laser pointer, all right. So you've got a standalone project that doesn't have any dependencies. Maybe it's got some NuGet packages or something. You've got a library and like an executable that uses that library. And then you've got like your company name .data structures or your company name .utilities. And then this giant stack of everything in the world depends on that thing, right? That's very common. And so what happens if you come in here and you change a line of code? So like you change this, and then you hit F5 to run or you try to run your unit tests again. What happens? Well, this thing needs to recompile. You change some source. It really does need to recompile. So it comes along, it recompiles this thing. That produces an updated DLL. Then the next project comes along and says, oh, one of my inputs has changed because that DLL has changed. So I got to rebuild. And then eventually, the cone of destruction extends to like everything, right? So this is like, hey, I changed a line of code here, or maybe I changed a comment here, and now everything has to change because everything is awful. In part, that is because in managed code, we have a single file, which is the DLL, the assembly, that contains the implementation, like the actual code that needs to run, and also defines the interface to that code, like the public interface. If you're in C++ land, a lot of the time you'll have a header that has, here is the interface, and then you have the CPP file that has, like, here is how we implement that interface. But your consumers only need to know about what is the interface, right? So if you make a change that is purely private implementation and doesn't impact the public interface, That changes the code, right? It changes the implementation, so it has to change the DLL. But if you knew that from the consuming side, you would know it didn't change, the public interface is the same, I don't need to rebuild. I don't need to rerun, I don't need to run the compiler because the public interface of the thing that I depend on is the same. So reference assemblies is a compiler feature that you can turn on. So you say CSC/refout:path, and that produces a new, different assembly that contains only the public interface. And then on the build side, we can come along and we can say, instead of looking at the implementation assembly, look at the interface assembly. So we come along and we take all these arrows and we point them to one that is slightly different. And because the compiler is now deterministic and this has just the public surface area, we can say, okay, and those are exactly the same. So there's no new timestamp, there's no need to rebuild, and we can just copy that assembly around. So let's do a quick demo. I just built, so I've got some stuff, so let me open up. Thank you. Even though I was in mirror mode, PowerPoint decided not to do it. All right, so let's come to the test bin folder. So this is where the tests actually run, right? It's got a copy here of a library that uses the data structures library, and it's got a copy of the test assembly. And these are all built, let's see. Well, they're built before now, as you can see. So, if I come in and say, hey, this is a bad implementation of Fibonacci, I'm going to turn off live unit testing because it kind of bogarts this demo. This is not a enterprise specific. This is available everywhere. Available everywhere except, let me describe that before let me bring you down before I can bring you back up again. All right, so this feature is currently only supported in new C# projects that have CS projects that are shaped like this, that use the SDK. The reason for that is that there are two things that care about what the compiler sees. There's the compiler at build time, and then there's also the IntelliSense engine at typing time. And when we switched the pointers to about like, oh, point to the interface implementation instead of the full implementation, that confuses the thing. So if you come along and turn on produce reference assembly, which is the MS-Buildy way to opt into this feature, in an old project, works perfectly on the command line, randomly doesn't rebuild in Visual Studio, which is probably not what you want. That's a known issue. The plan is to fix that in the 15.5 release, but right now, that's the case. And that's because there are actually two different implementations of the IntelliSense engine in Visual Studio. One is brand new for Dev 15 and is growing to eat the other one, but both are still around at the moment because we're trying to do everything very compatibly. So there are a few features that are not supported yet. So if you're using the old one because you have an older project, then it hasn't yet been taught about reference assemblies. So for the solutions where it would be the most useful, your big old solutions, it may not work. Sorry, we'll work on it. There's also a known issue that you can't combine reference assemblies with live unit testing. There's an active issue on GitHub for that as well. That'll be resolved before too long, but you can always opt out of it with this condition if you need to, like I did. Okay, so let's look at this bad Fibonacci implementation, and let's replace it with a good one, which is a nice way to do something that only, doesn't change the interface, right? It's still a function that takes an integer and returns an integer, but I can do it in a better way. I can do it iteratively. So let's do the current version. or the current number that we're calculating, int previous. All right, so we got the first two, then we'll say while I less than n, and then let's use fancy tuple destructuring assignment because I'm fancy. Previous, and previous are now previous and previous plus previous, right? Definition of Fibonacci, it's the current version is the sum of the last two. Here I'm just keeping track of two and I'm iterating, and then like I didn't do when I was practicing this, you got to change the loop variable and then return the last one. Okay, so I have saved that. Let me come into reference assemblies, tests, and do .NET test. Reference assemblies work just fine in .NET Core world as they do in full framework world. And so I changed some code that is in the data structures library. So that has to be done. So what you see now is data structures is new and updated. Library is new and updated. Hey, that's not supposed to happen. I knew I should have built it first. All right, so hold on. Let me come back here. Let me. Okay, now I changed it back, and you see data structures is updated at 12.17, but everything else is still 12.16. That's what's supposed to happen. It was supposed to be a more dramatic difference in time. All right, and then if I come back and re-replace all of that code, and then you can see the test fail because I made some error. And so here again, this is updated now at 18, but everything else is still at 16, and including like the test library, right, which obviously depends on something in this chain, but didn't actually do it. So let's see, I think I'm off by 1. It's because I shouldn't start at 1. Or start at 0. I should start at 1. All right, now it passes. Okay, so let's take a quick look under the hood of what's actually happening here. So let's go into the okay, there we go. So there are actually two copies of a file named awesome.datastructures.dll. There's the one that's just in the obj folder, and then there's one in a subfolder named ref. So let's look at what the difference is. There we go. All right. So ILDASM does not remember that I want big fonts. So looking at the disassembly of the code, there's this Fibonacci class, and it has a Fibonacci number, and it's takes an int32, and returns an int32. And the implementation of that thing here is the implementation of the code, as you'd expect, right? The jitter is going to see this code. It's going to produce machine code. It's going to run through it. Everything's going to be glorious because, you know, we live in nice .NET land. But the problem is, if I change anything in here, some opcode here is going to change, which means that the DLL must be rewritten. So let's look at ref / awesome data structures DLL. That is going to look very similar. Sorry, I couldn't find a way to permanently keep the font sizes big. So this is the ref version. You see the same things in this tree view because this tree view is looking at the public interface. And then when you actually look at the disassembly, it's really nice. It's throw null. And it's always throw null. That's because some tools get a little confused if you just always have empty method bodies. So instead every method body is replaced with throw null, which is valid, you know, like that's legal. You can run this, you can attempt to load this assembly at runtime and use it. You will be very sad because it will throw null immediately, right? But when the compiler is coming along and saying, oh, what is the public interface of this thing? It's exactly the same. And what we can do is we can say, we always point to the reference copy of the assembly, which means, and then we can not update that as the compiler is coming along. This should be very nice in terms of performance. Some folks on the Roslyn compiler team were able to see that, like, some changes that had happened in the Roslyn solution itself, which is pretty big, takes a while to build. You could see that some changes would take like 80% less time if you do the build that goes through the reference assemblies, because a lot of bug fixes happen in implementation, right? Oh, it's like this method said add, but somebody typoed like a minus sign in there. You're like, that's an easy fix. And it doesn't impact the public interface at all, so it's kind of unfortunate that you have to drag through all this stuff. But of course, if you do change the public interface, this gets you absolutely nothing. The nice thing is, it doesn't really cost you anything either. The way the compiler implemented this is it just opens a new stream for the reference assembly, and just whenever it sees public stuff, it feeds it to that stream as well as the regular stream. So, you know, like there's very little overhead. Internally at Microsoft, we had solutions like this that were like, come back and post-process every DLL, and, you know, run as a separate process, and it was always fragile and terrible. Now that it's built into the compiler and it's just to like emit to another stream, it just emits them both all at the same time, and everything is very nice. So, action item for y'all: be on the bleeding edge, use the new style projects, and then opt in either in directory.build.props to apply to all of your projects, or at an individual time with this produce reference assembly true. It does require opt-in right now because we don't know where this causes problems other than the places that I've mentioned, right? It cause problems with live unit testing, cause problems with the legacy project system. So we know it can cause problems. We don't know what all those problems are. Both MS Build for the build side of this and Roslyn for the compiler side of this are open source and on GitHub. And if you, after you have turned this on, because you're all going to do me a favor and turn it on and figure out what the story is on everything, please file bugs and let us know. And we would like to be able to turn this on by default at some point in the future, and we can't do that if no one opts in and tells us what's going wrong. So please do, that'd be awesome. And don't forget this little cartoon up here saying you can report problems and provide suggestions. We totally, actually, for real, listen to that stuff, even if it takes a little longer than you would like. Any questions or anything? Like I said, there's totally a ton of more stuff that I don't know about. I wanted to do cool demos of debugging in a container, which is another headline feature of VS 15.3, but Docker won't install on my laptop for some reason, so that all got thrown out. But you can do things like you can build a Linux container, run .NET Core applications that run on Linux in Docker on your Windows machine, and then you can deploy the Docker images that get built out of that directly to Azure App Services. So like that's a very cool development workflow. That's the hot in the web world. So I wish I could have demoed that. Sorry. Questions, comments, concerns?